Cohort topic 3, problem number 22 is an example of raw data being given in a table this time, and questions about probability being asked. And probability is simply the relative frequency, that is, the size of the event divided by the size of the sample space. So we have to examine each of these questions and carefully figure out what is meant by the whole group for that question and what is meant by the special event that we're finding the probability of. And then we simply make a relative frequency amount over total amount. So let's see. Students, certain high school, gender male, female, pierced, yes, no. So a simplistic survey just gives us 4 results from the 2 variables. And of course, it gives us all the totals that we would want. Row totals, column totals, and the total, the 500 students that were surveyed. So let's interpret the questions. What is the probability that the student has one or both ears pierced? Oh, well, that's just the amount of pierced divided by the total number of students, right? One or both ears pierced qualifies as pierced, and there are no conditions on this. Probability of the student, that's a randomly selected student. So we can immediately see that the sample space is the 500 and the sample size is pierced people. So that's the 324 total. We have no mention of gender, so we're just looking at column totals. That's the probability, which is really just the relative frequency, size of the event divided by size of the sample space. Let's see if the second one is equally simple. What is the probability that a student is male? Yes, that's equally simple. We're not inquiring at all about the pierced or not pierced status, so we can simply focus on the male total. This is all males, 180, out of a student population of 500. So just as part A, no conditions, no special mention of any particular kinds, then it has to be the student. That's a random student out of 500. And we simply put the number of males on the top. Relative frequency is size of the event divided by size of the sample space. What is the probability that the student is male and has ears pierced? Okay, so we just got male and ears pierced. Maybe we even wrote them down as probabilities. If you like to pull out your calculator, please do not multiply. You can only multiply probabilities to find out this and that if this and that are independent. And the only way to find out that they're independent is to know it from context, such as flipping coins and rolling dice don't have magical effects on each other, so they must be independent. Or if you actually check the numbers and when you take the product, the raw numbers that you gathered match, then you know that's your evidence that the 2 events are independent. But here, we have data for everything. What's the probability that a student is male and has pierced ears? Well, that's the 36 students that are male and have pierced ears out of, again, it's still out of the 500 because the student, we weren't told, oh, it's a male, so there's only 180 of them. We weren't told, oh, it's only pierced ears, so there's only 324 of them. We were told a student, and then we're just looking for the 36 out of 500. As always, event divided by sample space. Third question, what's the data? What's the question? Given that the student that was chosen is male, aha. Now we can still figure out relative frequency But now we know the bottom of the fraction can only be the 180 males because we've got a male. What is the probability that he, right, the male, has one or both ears pierced? Well, we do know that 36 males have pierced ears. So we have to take that event of a male with pierced ears and divide it by the number of males, because the sample space for this question, this conditional question, is being male, and there are 180 of those. This is actually conditional probability, right? Any given should be computable as if it was conditional probability. So let's just do it, right? Probability of pierced given male, right? We know just from formula without thinking at all, although I would like you to think about why the formula makes sense, right? We want the probability of the intersection divided by the probability of the given condition. Intersection over condition. Well, those are exactly the numbers we have to the right. We can figure that out from common sense, from the language of the question, or we can figure it out from noticing it can be represented with the symbols of conditional probability and therefore computed with further symbols for conditional probability.